All right, in this lesson we're going to be looking at the graphs of square root functions and how they are transformed. So we get the graph of a square root function from the inverse of a quadratic function. If we take the square root of both sides, we get, or if we try to find the inverse of y equals x squared, we interchange the x and y, and we get x equals plus and minus the square root of y, and that is what the graph of the inverse of x squared would look like. However, as we established already, the inverse of a quadratic function is not itself a function. It did not pass that horizontal line test, and we can see from the graph of the inverse that the inverse is not going to pass that vertical line test. So the inverse is not a function, so we're just going to focus on just the positive part of that graph, and that is the square root of x. Y equals the square root of x. And we learned in a previous unit, the domain is the span of all the x coordinates. The range is the span of all the y coordinates. We should also be able to identify the vertex and then two other points on that graph. We should also be able to determine what y approaches as x approaches positive and negative infinity. So for the domain, we can see that the span of the x coordinates is from 0 to infinity, and the range is the same. It's also 0 to infinity. And then 3 points that we have on the graph is the vertex at 0, 0, 1, 1, and we get that by plugging in 1 and 2 for x. Square root of 1 is just 1. And then when we plug in 4 for x, square root of 4 is 2. That's how we got the coordinate 4, 2. As x goes to the right, or approaches positive infinity, the y just keeps getting bigger and bigger and bigger, so it approaches positive infinity. As x goes to the left, it's going, y is going to get closer and closer to 0. It's going to approach 0. We also learned that in a previous unit that A tells us whether the graph is going to be vertically reflected, stretched, or compressed. B tells us whether it's horizontally reflected, stretched, or compressed. H will tell us how it moves from the left to the right, how it's translated to the left or right. K tells us how it's translated up or down. All right, first example. So we can see that A is -3. So when we're describing it, we want to separate those two transformations. So let's start with the negative. The negative is going to reflect it vertically, and then the 3 is going to stretch it vertically. It's going to stretch it by a factor of 3. The domain, you should do a quick graph of what a quick sketch of what the graph will look like. The domain is going to be, now notice that because of that negative, it's being reflected vertically. So this is what the graph is actually going to look like. And that vertex is 0, 0. So the domain is going to be from the x coordinate of that vertex to infinity. And the range is going to be the y coordinate of the vertex to negative infinity, because the graph is going down as you move to the right. Next example, let's start with the 5. The 5 is going to stretch the graph vertically by 5, a factor of 5. The -8 is going to translate the graph to the right 8 units. And then the 1/3 is going to translate the graph up 1/3 of a unit. Again, we should do a quick sketch of the graph. It's not being reflected because A and B are both positive. So that's what the graph looks like. The coordinate of the vertex is actually 8, 1/3. So the domain is going to go from 8 to positive infinity. And the range is going to go from 1/3 to positive infinity. Next example, the domain. First thing we should do is do a quick sketch of the graph. Again, it's being reflected vertically because of the negative a. So that's what the graph would look like. We should start with the vertex. Vertex is at 1, 3. H is 1, K is 3. And so the domain is going to go from 1 to positive infinity. And the range will go from 3 to negative infinity since it's going down. As x approaches positive infinity, or as x goes to the right, the y-coordinate is getting lower and lower and smaller, more and more negative, so negative infinity. And as x goes to the left, it's approaching that y-coordinate of the vertex. So it's approaching 3. All right, for another point on the graph, if x is 2, when we plug in 2 for x, we get 2 minus 1, which is 1. Square root of 1 is 1. Negative 1/2 times 1 is negative 1/2. Negative 1/2 plus 3 is 1/2. When we plug in 5 for x, 5 minus 1 is 4. Square root of 4 is 2. Negative 1/2 times 2 is negative 2. Negative 2 plus 3 is negative 2 plus, all right, so we had 5, square root of 4 was 2. Negative 1/2 times 2 was negative 1, and then negative 1 plus 3 is 2. All right, one more time. So start with a sketch of the graph. Again, the x up under the square root is negative, so that means that b is negative, so it's being reflected horizontally. All right, so that's what the graph would look like. The domain is going to go from, first thing we should identify is the vertex. H is 0 and k is negative 3. So the domain is going to go from negative infinity all the way to the x coordinate, which is 0. And the range is going to go from the y-coordinate, negative 3, all the way up to positive infinity. As x goes to the right, the y is getting closer and closer, all the way to the y-coordinate of the vertex, negative 3. As x goes to the left, y is getting bigger and bigger and bigger. It keeps going up, so positive infinity. And if the x-coordinate of another point on the graph is negative 1, negative 1 is 1, square root of 1 is 1, 1 minus 3 is negative 2. And then if the x-coordinate is negative 4, negative 4 is 4, square root of 4 is 2, 2 minus 3 is negative 1.